as astronomers search for a Death Star named Nemesis that might periodically cause mass extinctions on Earth. The recent discovery of a tiny world named Sedna could prove key. Billions of years ago, Sedna revolved around our sun like other planets in a nearly circular orbit. But then, two strange things happened. First, something forced Sedna into an extremely elliptical orbit. And then something else pushed that orbit out so far that it seems to defy any visible explanation. The first question, what caused its elliptical orbit, is fairly easily explained. It could simply have been gravitational tugs from the outer gas giants Jupiter and Saturn. A trampoline can help illustrate.
To really understand how orbits in the solar system work and we get these very elliptical orbits, we need to get more height on the trampoline, and I can't do it. So Ken, I'm going to need your help.
Well, awesome. I'm ready to help.
Let me get out of your way.
Just as extra people on a trampoline create extra bounce, the large gas giants in the solar system can create enough gravitational bounce to stretch a smaller body's orbit into a wide ellipse.
So here's Sedna on a nice elliptical orbit, but then Sedna got a little bit close to one of the planets. As soon as it does that, the extra gravity of the planet gives it a little boost into an even more elliptical orbit, but then it gets close to another planet, let's say Jupiter. Here comes Jupiter. It bounces even higher. With enough bouncing from Jupiter, we could bounce Sedna all the way out of the solar system.
The orbital bounce provided by Jupiter and Saturn can explain how Sedna's orbit got its elliptical shape, but not how it ended up being forced into a distant region of the solar system, where scientists never expected to find a planetary body.
Sedna was on an elliptical orbit, getting further and further and further, and then something happened to it when it was out here. Some other gravitational force pushed it off into a different orbit, and so it didn't come back to the same place it was before.
It's as if some second gravitational force was passing by and shoved Sedna onto a different trampoline so that it bounces in an unexpected region.
The most likely answer is that there was another star very, very close to the sun at the time when Sedna was going through this process.
The solar system probably formed in a cluster of stars, and so close encounters with nearby stars, nearby rogue planets even, were much more common during the very earliest days of the solar system's formation.
Most of these solar brothers and sisters have long since dispersed. But according to the Nemesis hypothesis, one of them is still out there, still circling the sun, still causing periodic chaos amongst the comets, and still waiting to rain death on the Earth once more. If that is correct, future generations will be faced with a monumental threat when Nemesis returns. In 10 million years.
The Moon, Mars, planets would basically be unaltered from their current condition. On Earth, the cities might not be there, but the continents would still be almost in exactly the same places that they are now.
But according to the Nemesis hypothesis, a major change is underway 1 light year from the sun. A dark reddish star has entered the Oort cloud. Nemesis has returned. If humans still exist on Earth, they'll face a slow-building but imminent cosmic threat.
The Oort cloud contains perhaps 10 trillion comets, maybe even more. But remember, it's really big, so if you were in the Oort cloud, it's not like you would be pelted by comets all the time. The spaces between them would be pretty big.
Like a bowling ball in a juggler's hands, Nemesis simply shuffles some comets out of its way.
the Oort cloud has an empty region in the middle. It's been cleaned out by Jupiter and by the Sun. We live in that region.
But as Nemesis approaches, the inner solar system becomes a shooting gallery.
And so there start to be a few more comets than usual, and then suddenly there are just comets coming all the time.
And at the peak, there might be 1,000 to 10,000 comets per year in the sky.
According to the projections, Earth would be in the crosshairs of this comet storm for 1 million years.
Over a period of 1 million years, there would be visits by about 1 billion comets. Well, actually, you do the calculation, it turns out one of them will hit the Earth, 1 or 2.
It would be difficult to predict exactly when the impact would happen, but there would be this phase, this sort of danger zone in which the chances for a catastrophic impact with something of a comet size would be much, much higher than they are now.
Will the impact spark another catastrophic extinction on Earth? Perhaps, but only if we let it happen.
I like to joke that Nemesis planned this one poorly. In between the last extinction and the next one, there's plenty of time for intelligent life to get its act together to make sure that next time Nemesis comes back and the sky is filled with comets, to make sure that none of them hit us.
Is this future inevitable? Until scientists either discover Nemesis or definitively rule it out, no one can know for sure.
It's important to realize this is not just an abstract discussion. Clearly, these objects colliding with Earth happen very rarely. But on the other hand, when they do collide, they're extremely cataclysmic. So what we need to be able to do is get better understanding of our solar system and keep an eye on the sky, because it may be crucial for our survival.